Hello and welcome to the next lesson, Case Study 3, Video Streaming Service. Let's get started. The situation is that Emily wants to create a simple video streaming platform for local creators. This platform will allow users to upload, store, and stream videos. It aims to help small creators and their audiences by providing reliable video playback and upload options. The platform will focus on these core features without adding social interactions or analytics. Emily must ensure the platform can handle video uploads and convert videos for playback, storage, and streaming. The requirements. Users should be able to upload videos. The system should help video clients adjust to changing connectivity conditions. The system should be able to store videos. Videos should play smoothly with little delay for everyone. And lastly, only authorized users should be able to upload or view specific videos. Now let's get started on the design. All right, of course, for everything, we always got to have the user, little smiley face, got to put it over there. So first thing is that, again, I mean, you're going to see this in a lot of the systems. You're going to have some sort of web service that gives you the people the ability to actually, see your website and interact with your service, right? So we're going to put this box here. Let me go ahead and copy and paste this text file, then go in. I'm gonna call this a web notice. All right, so we have that going. Okay, now again, we also, it's a video streaming service. We want to make sure that we have all the metadata and the information about video streaming, all the videos that are being uploaded. So we want to actually, again, have our separate data layer service that we've had before that has like a service back, connected to a relational database. This enables us to centralize all of our business logic into one point. So we go ahead and put this as the data layer service. All right, let me make this a little longer. Move this over here. Let me give me some more room. I'm actually going to push this up to make sure we have this here. So, okay, so we have, actually I'm gonna move this up here to have this going, right? And then remember, we have over here, only authorized users should be able to upload or view specific videos. So because we have that, we need to have some sort of way of authenticating users and making sure they can view the right ones and handling those permissions. So we'll go ahead and do our service connected by key value store to introduce our friendly auth service that we've mentioned. We've had both in case study 1 and 2. Okay, service. All right, so we're doing this here, and then go ahead, hold on, and let's go get the elbow connectors. Connect the user to auth service, which connects to the web service, and goes to the data layer. Awesome. Now here's the thing that's interesting. So if this was just like, case study 1, we had the whole block service, and we had then we just have the raw file service, media cache service, server images, serving text, we're all good. But this is video. Video is interesting. Video is bigger. Video has a streaming time component. You have to make sure that oh, hey, we want to view the video and streaming as quickly as possible. Videos these days can be really big. These videos that I'm recording are gigabytes, large, very big. And even though we have, a lot of people have relatively fast speeds. One, not everybody does. And remember, one of the requirements is that, the system should help video clients adjust to changing connectivity conditions. Video should play smoothly with a little delay for everyone. There's that aspect. And 2, even if you have really fast internet, who wants to download gigabytes before you can upload stuff? You just, you go on any video streaming site, you press play and you're playing, right? How do you make that work? So you think about it, again, I mention this because the goal of these system designs is not to say, hey, this is the greatest way to design a video streaming system. I'll tell you right now, this isn't the best way. There are other ones that are way more advanced than what I'm talking about here. What we're saying, though, is that we are breaking down these concepts of how to build these things into these building blocks. So you can get that senior level intuition to see okay, these are some of the considerations we have. This is how I can combine the things I know in order to build a system that I haven't built before. Then when you become more complicated, optimize it more, you know where you can go to optimize, you know the different services you can do to make it, to improve it. So that's the goal here. So that's why I'm connected here, because here with the video, the difference between case study 1, the blogging service, and this video streaming service in case study 3 is the media is a lot more taxing. You're talking about video. You're talking about people trying to stream video efficiently. So we have to do more in the media side in order to make that happen. So what do we do? So one of the things that's common to do these days is that you take a video, and if you notice, if you go to any streaming service and you're opening a video, you'll notice that like, oh, you're playing, and if you stop, you notice that a little bit is like kind of downloaded, and like even if you lost internet, it's still saved, but then it stops. It's because it's chunking these videos into small pieces, okay? And so there's chunking into small pieces, so you don't download the whole video, you download small pieces of it. In addition, to make sure, there's lots of different formats of video out there, and some are better for different situations and different client situations and different connectivity situations. Some videos in these chunks can be in different formats, so that's just like, oh, hey, this format is better for a person that's using a cellular connection. This one is better and because this person has like a direct cable connection. So you have these two kinds of dimensions here. So I say this in order to prepare for what this system can look like. So first off, at the end of the day, though, we're going to need some sort of raw data file service. That doesn't change. You're going to still need a place to store the stuff. So let's go ahead and put our raw file service here. I meant for a file service, not raw data service, right? So we'll still need that, right? But we're going to need some processing beforehand. And actually, I'm literally going to call it that. We're going to have a queue connected to a service. And we're going to call this quite literally the video processing service. Because basically what the idea is that when somebody uploads the video, we're going to do a bunch of pre-processing beforehand so that when people view the video, they'll be able to read it. Now, let's talk about intuition here. Even though video, this is all different. This is not that different from what we've already did in case study 1 and 2. Case study 1, we had blog posts. So we had like the text, we put in the cache so that people can read it really quickly, right? And then we had in the media file cache and the media file cache, and so you can get the images really quickly. Case study 2 in the social media platform. What we saw is like, we wanted to have feeds to be very quickly to people to be able to access feeds because that's the home page essentially, and that could be computational. So what we did is we had like a regular 15-minute job that calculated and got all the new posts that happened, and it updated that cache. So we had some processes to keep the cache up to date. Now here, what we're going to do is when somebody uploads a video, we're going to do a lot of processing beforehand so that the stream will be, like the read part will be good for the user. You'll see this common thread over and over again, but you also see just various different systems that are done pre-processing or things are done on an ongoing basis to ensure that the user gets that good user experience. So this is just yet another way of doing that. So you have this video processing service that when somebody uploads a video, let me go connect this over here. Also, I want to make sure to note that this web service is also connected to the raw file service, because when somebody uploads a video, we want to make sure that video is saved. That video in its raw form is saved there as well. But then it's also passed to the video service. There's and it gets in a queue, and that queue kicks off workers in an order. So we have a worker here, and this first worker is called, remember those two jobs I mentioned about, 2 tasks that needs to be done. First is the transcoding worker. What this does, it takes it takes your video and converts it in all these different kinds of formats. Some are better for high bandwidth, some are better for low bandwidth, and so on and so forth. So we have that here, right? And then we have another worker here, which we'll call below the chunking worker. And this is the one that splits all of these different videos, which are now in different format, into small parts, like maybe a few seconds long. It depends on what's good. So that now you have all of these files that are in these chunks, time-based, time-based essentially. What's the purpose of this again? Is so that we have all of this information so that we give the user what it needs to be able to select the right chunk for their current situation. If they change, maybe somebody's on Wi-Fi and they convert it. Have you ever seen that you're on Wi-Fi and then let's say you leave your house and you go into cellular phone and you notice that your videos is blurry or something like that? That's things that are dynamically changing based on your environment. And here, the dimensions we have here is that we have different formats that some of them are good for different situations, and then everything's chunked so that the client can select the next few chunks that's best for their current situation. So hold on, let me give some lines here. So this video processing service, one thing you'll know is that all of these areas are connected to the file service because everything is saved. The raw file, all the different versions that it transcoded to, and all the chunks for all of the ones that have been converted as well. All these are saved, okay? And then, as you may have guessed, this is all in preparation for our friendly media cache service. That, we still need that because that is still the most efficient way to save, to pass static assets to the user quickly as possible. And like what's in there is especially important is all of the chunks of all of the video in all the different formats so that the user can select what it needs to. Now you might be wondering though that like, okay, oh, hold on, let me get the lines out first. So you have all this, and then of course this file service has to be all the way connected to this media file service. And let's see if I can just move this over here. Nope, I messed up. Over here, no, come on, here we go. Okay, so, and then of course, this media cache, and let me just complete this media cache is connected to user. But then you're just like, okay, I've never watched a video and be like, I'm gonna select this one or that one. You may not, and of course the client would automatically update it. But have you ever watched a video and it says like, oh, hey, what resolution you want? You can change the resolution. Then that's when you are actively changing which chunk you're trying to get from this media cache service. That's what's happening there. So the client, this is when, again, right here we have the system requirements. The system should help video clients adjust to changing connectivity conditions. The way it does that is by providing the chunks of the whole video in a number of different formats so that your client that's on your browser or what have you can has the ability to select different chunks based on the time of what where you're watching, dynamically streaming so that it can adapt, because your client, like let's say your phone, knows your current internet connectivity. It knows its hardware, and because of that, it can select the right thing from the media cache service. So a lot of video clients on websites have this ability. So that's how this system works. So you have this. So now, actually, this is basically our system. So we can upload folder videos. You authenticate it, go to the web service. It's saved. The metadata saved in the data layer service. It gets processed, transcoded, and chunked. Then the results get saved to the raw file service, which is passed to the media cache service, which the user can be available based on the video player, right? The system can help video clients adjust to changing connectivity conditions. I mentioned that with the chunking. It should be able to store videos. That's why everything is stored in the raw file service, including the original upload. Video should play smoothly with a little delay. That's how the chunking and transcoding helps with that. And only authorized users could be able to upload or view specific videos. That's why we have the auth service here before we can do that. Because when you go ahead and authenticate, we want to make sure that, okay, that person can actually view the video, and that's what gives the people able to connect to the CDN to the right resources. So this is our system, and it hits all our requirements. So let's move to our takeaways. All right. So first key takeaway: breaking video files into smaller parts allows the client to choose the best version based on the speed. The system creates these parts by using a queue that connects to the service managing these requests, which we call the video processing service. All right. Second key takeaway, the client plays a vital role in the system. The video client on their side knows the current internet speed and which video chunk it needs. The video player on the client side decides which chunk to download next from the media cache server. All right? And the third key takeaway, the video processing service handles tasks with two types of workers, transcoding workers and chunking workers. Transcoding workers change the video into different formats so clients can choose the best format for their internet connection device. Chunking workers break videos into smaller pieces, allowing clients to download the proper format for the next few seconds of the video based on their internet connection device. Both types of workers save their data to the raw file service, which updates the media cache service to make those chunks available to users efficiently. So these are 3 takeaways. Thank you so much, and I'll see you in the next lesson.